What's up, everyone? Buckle up for a new episode of Tech in Check. Let's dive into the basics and complexities of machinery maintenance with engineers Rich Marriage and Tony Planamento. Join us as we meet with guests from the marine and industrial world to learn about the latest technology that keeps your equipment in check and working for you.
Hello, my name is Rich Marriage. I'm with Advanced Mechanical Enterprises. We're a company that specializes in vibration analysis and laser alignment of rotating and reciprocating machinery for marine and industrial applications, and helping vessels and facilities diagnose issues before they become failures. I'm here with Tony Planamento.
I'm the technical project supervisor here at AME. And like Rich said, we're here to let you know what your machine's saying.
Most people don't realize how much machinery talks, right?
Yeah.
And vibration analysis is how we listen.
Yeah, it's a good way to put it.
Yep. So what is vibration analysis?
That is a very loaded question.
Yeah.
So vibration analysis is actually, to put it rather bluntly, it's the analysis of the vibration. There's a few different ways to do that, right? You've got, I guess technically it starts off in just physical motion, right? Like displacement. It just up, down, left, right, vertically.
Yeah, it's measuring. It's what we're doing is we're almost like measuring, like when you go in for a doctor for an EKG. We're using vibration signatures and direction and phase to determine what's going on, right? To break down, to identify machinery problems. And it's a relatively quick and easy process, and it gives you a lot of powerful information, right?
Yeah.
So each machine produces vibration and has recognizable patterns of vibration, and we're here to we'll lightly touch about that. And from these vibrations, we can pick up things like bearing wear, misalignment, unbalance, gear issues, and among others, right?
Yeah.
Structural problems.
Yeah.
Foundation problems.
It all comes down to the individual components in the machinery, the geometry of the bearings and stuff like that, and how many teeth are in a gear.
Yeah. And all that gets set up in the database up front. Little more work setting up. Once we set up a database, once that initial phase is done, it's much easier to continue on. And one of the things that is a huge benefit to plant reliability is doing condition monitoring. And that setting up the database is the key.
Oh, absolutely.
Garbage in, garbage out, right?
Exactly.
Set it up right from the beginning.
No, you got to do that right. And then from then, like you said, you can trend the values. And as they start to go up, you can start doing a little more disruptive work to dig in and figure out what's going on. There's different levels of vibration analysis, right? So you have your level one, for lack of a better term, is just kind of that overall, health check, red, yellow, green, stoplight stuff.
Sure.
You've got your second
dashboard.
Yeah. You've got your second level where you start to get into your spectrums and your spectral analysis. And now there's when the detective work really starts. That's where that EKG kind of stuff comes into play. It's really just pattern recognition, right? So it's, how many times per revolution is it impacting?
Yeah. Condition monitoring versus diagnostic, like really more advanced testing.
Yeah.
Or commissioning when a machine first comes online, or after major maintenance, right?
Yeah.
So, we can tell from the signature what's going on.
Yeah, absolutely. So if we're trying to do that kind of high level, quick screenshot, we'd probably use the Vibe Scanner data collector, right? The Vibe Scanner 2.
Which is a highly portable device. And
very easy to
use.
Yeah, you teach your guys how to use that.
And our customers are able to use that with our assistance. Once we set up the database, they can run it without us.
Yeah.
They can, with the RFID tag, it identifies the point, and then they can just take data.
But what's really was kind of an unintended benefit to that was when COVID hit, right? Like you couldn't really get people into your plants. You couldn't get people onto your vessels without getting a test or what they call it, quarantine. It was really a unique solution to be able to say, here's a data collector. Yeah. You guys go out and collect that data, send it to us, and we can analyze it remotely and give you a report.
Sure. That Vibe Scanner is a very easy to use and very powerful information.
Yeah.
Yep.
Yeah.
And of course, if something pops up that's more serious, and of course we could always go in with the heavy artillery.
Yeah,
right.
That's when we would probably break out our actual dual spectrum analyzer, the Vibe Expert 2.
Yeah,
right. And then that's really where,
or we're multi-channel analysis, right?
Yeah. If a standard vibration analysis doesn't come to that conclusion,
or we got a lot of stuff in our arsenal.
Yeah, we got some toys.
All right, and we're essentially reading a machine's heartbeat, right? We're looking at making sure it's running right and it's where it wants to be.
That's
right.
It's like I always tell people,
no blood clots.
we're like doctors for machines.
Yeah,
like
exactly.
We walk around with our analyzers. It's like a stethoscope. It gives us a chart.
Yeah,
we read that chart. We say, okay, this is what's wrong. This is how you fix it.
And then, we talk about what's the process of, maybe you can elaborate a little bit, like what's our process of doing vibration analysis? We show up at a plant. What do we do? How does this work?
Well, like you said, preparation is key, right? Garbage in, garbage out. So ideally what we want to try and do up front is get any and all relevant mechanical details for the machinery that we're measuring.
Sure.
Your production gear ratio. If we can get a picture of the ID tag, that would be helpful because that usually identifies what kind of bearings are in there.
Yeah.
And then we can pre-program the known fault frequencies
of the bearings, of the, so knowing the more details we have about the machinery,
the better.
The better, more honed and precise our analysis can be.
Exactly.
But we have a lot of experience.
Oh yeah.
And sometimes we don't even need that stuff. We're so good.
Yeah. That's the positive about it. That because we've done so many and we know we have that experience, it's not an all stop if they don't have that information.
Yeah.
Right. We can rely back on our gained experience.
Yeah. We're almost 34 years in business. It's a lot of years, a lot of vibration signatures. So, and then, we want to highlight, we're not here to teach vibration analysis, but we're talking about like sensor placement, the type of sensors, all that stuff is important.
Yeah, absolutely.
Well, you got to have the right equipment for the job, the right sensors for the right frequencies.
Yeah.
I remember a case where a guy thought he had a vibration. He was misreading the vibration because he didn't have a sense. He thought everything was good, but he didn't have the sensor picking up the low frequencies that were indicating a structural problem.
Oh, wow.
So you got to have the right sensor.
Yeah. Well, thankfully, the ones we have now, they have a pretty wide range. Yeah, they can get down to, 0.1 hertz.
Yeah, it's amazing.
6 cycles.
Those line drives, and they're really powerful.
Yeah, absolutely. So once we get all the preparation phase done, we would obviously attend either the plant or the vessel. If it's a vessel, we want to make sure we get there in time to measure the mounts, make sure the deflections.
Yeah.
And then, if you have time.
If they have mounts, right?
Yeah. And if you
do a pre-work inspection is what you're advocating.
Exactly.
Yeah. I mean, it's like when you go to the doctor, again, to give the analogy, but when you go to the doctor, he asks you questions.
Yeah.
Hey, how you feeling? What's your history? All that stuff's important to what we do as well.
To the diagnostics,
to be able to troubleshoot and that's for a diagnostic survey. For condition monitoring, that's once you've done the initial plant survey and you understand everything, the next surveys are a lot more, you're looking back at the data you've already taken, the history of the plant, you're starting to, there's some repeatability there, some consistency, which all that helps, right?
Yeah, absolutely.
And, the more, and then, depending on your operation, this critical machines probably should be monitored more closely, right?
Yeah.
Maybe even having continuous monitoring with wireless sensors and all that.
Yeah.
And non-critical assets, maybe you don't have to survey them as much. And that's why you do an asset criticality analysis.
Yes, exactly. Yeah.
Yep.
That's a big thing that, most of our customers don't really tend to do that. And it's kind of where we can actually help.
Right. Help them out. Yeah.
It's not just how critical is that component to your production line or to operations. It's also environmental and safety issues that you have to consider as well.
Sure.
Sure. If you're talking about an ammonia pump or an ammonia compressor, if that thing fails, you're going to lose refrigeration. But if your seal's leaking because of a misalignment, you're spewing ammonia.
Don't want to be in that room.
Yeah, exactly.
Running machine under load. That's something so when we do the testing, a machine's just running without any load on it, it's kind of not really telling us what we need to know. So that's one of the things that's very important too, is to get the operating conditions of the plant, where, or the machinery, is it the conditions? Is it pumping a fluid? Is it pumping air? Is it pushing a conveyor belt? All those things matter, right?
Yeah.
It's not just, just measuring it with no load on it. Things just freewheeling, right?
Yeah.
No stress.
Exactly. And so that's, like you said, with
It's like riding a bicycle with no friction.
but like, yeah, I mean, like you said, it's you want to keep things as close to their operating conditions, normal operating conditions as possible. And if you don't know those normal operating conditions, perhaps it's, a new captain on a yacht or a new plant for commissioning, then what you typically want to do is set it up that 80% range.
Right.
Because that's going to kind of make any underlying defect flare up.
Well, and then that brings up another interesting point, right? With speed and, RPM. So everything in nature vibrates, right?
Yeah.
Everything in nature has a frequency that it wants to vibrate at.
Yep.
Even the human body, right? Everything has a natural frequency. And, when you're on a variable speed machine, it's good to know where that frequency is, where all of a sudden it's inharmonic and it starts to like amplify the vibration. And then it's surprisingly enough, when you speed up, all of a sudden it goes away.
Yeah.
I've experienced that with my truck, like a certain RPM, you feel a little vibration and you go a little fast and it goes away.
Maybe you got to get your engine mounts checked out.
Yeah. Hey, I know somebody that broke,
You might know a guy.
I know somebody that broke their engine mounts. Pushing it a little hard, but got out of that natural frequency.
Yeah.
All right. Well, everything is related. Speed, excitation force frequencies. If they line up, this thing's going to shake like crazy, right?
Yeah.
So, what we do is with the FFT, we're looking at spectrum data. We're looking at the frequencies, and from like those frequencies, we're able to identify through pattern recognition, what if it's a misalignment, if it's a bearing frequency, because again, these things cause excitation forces, which we're able to read.
Yeah.
Right? Yeah. So it's a very valuable vibration analysis, is a very powerful tool, and
yeah. Well, the technology is incredibly powerful, but it's also important that you have, again, an experienced analyst that knows the machinery and knows kind of the different nuances of each machine.
Yeah.
So I don't know if you remember the time I went up to the Philly shipyard and we were working on an engine.
Yeah.
They had another vibration analyst come in.
Sure.
They saw second order, right? And that analyst was more kind of land-based.
Land-based, right.
So second order and land-based means misalignment, right? Well, what he didn't realize was this was an 8-cylinder engine. And the 8-cylinder engine, it's cylinder bank firing frequency of that engine lined up with the second order.
Right.
So it ended up actually being an engine issue, not an alignment issue.
And, it's easy for those land-based guys to make those mistakes. That's, we got that ABS condition monitoring certification.
Yeah.
And earned that. We earned that.
Well, I mean, but what needs to be remembered is that land-based is, it's all ideal. Like, so much engineering has gone into setting up that plant, pipe runs, electrical runs, machinery placement.
Oh, they should have.
Ideally. But
get some young engineer designing out these pump placements, and you're like, what the heck is that? What were they thinking?
Yeah, right. But
the pipe runs.
But on that land, you're stationary.
Yeah.
You're solid, you're fixed. And
right.
Once it's set up and you kind of work out all the initial kinks, everything's, should run smooth.
Right. Should run smooth.
On the marine side, I mean, you got to think it's a plant on the water, right?
Right.
I mean, that whole thing.
The hull has a certain degree of elasticity, right?
Yeah.
The structure moves.
Yeah.
Plus, then you got things like stray currents and, somebody welds on the hull and next thing you know, you've got a bearing that's arcing and you don't even know it.
Yep, exactly.
All these crazy things.
Exactly. I mean, it could get so sensitive to where it's just the amount of fuel you have could make the hull
shapes.
And that could throw out the alignment.
People assume things run forever, but, components made out of rubber, for example, couplings, engine mounts, they're subject to wear and tear. They wear out, typically run around 10 years for these rubber components, depending on, the operating conditions it was exposed to. But on average, 10 years. Right. So, you get some settling of the engine mounts. It's called creep.
Yeah.
You get some twist in the elastic coupling over time. And, if those things aren't addressed, they can cause vibration problems. Right.
Yeah.
So
that's a lot of the reasons we get called out is let's say, something gets taken apart, perhaps something like that rubber coupling.
Sure.
And when it goes back together, maybe it wasn't put back in the exact same position that it had been running for 10 years. So that twist is now in a different location, and that starts to excite
a lot of new dynamics.
Yeah,
right?
Exactly.
And you got all these other things to worry about: connections, water connections, exhaust connections.
Yeah.
On elastic mounted propulsion machinery, it gets a bit tricky, right?
Yeah.
Now on hard mounted machinery, you got to look at the chocking and is something changed in the hull structure, right? That's on a marine application. Same thing with industrial, right? Industrial, like you said, once you get through the initial commissioning, right? You've eliminated pipe resonance, pipe strain, you've got a good alignment, you've got solid foundations. That thing should, that'll run for 50 years without any problems, right?
Yeah.
Exactly. Until somebody touches it, changes it a bearing, and all of a sudden everything's all out of whack.
There's always the human element, right?
Yeah, exactly. So we come in and, after work is done, it's always good practice to get a good baseline vibration after, right? A commissioning, after major maintenance or after a new commissioning. That's why, it's good to do this stuff to make sure you have a 50-year machine and
absolutely.
Those bearings are run their full life.
For sure. Right. It's not only that, but it keeps your contractors honest,
Yeah.
Because
they're always honest. Come on.
But, if perhaps some of that human element.
It's a good quality. It's a good quality check for sure.
Yeah.
Right. That's what we're.
That it's running the way it should.
Yeah. You could definitely advocate for that. So, we were land versus sea. We kind of touched on this a little already. But, when we do a sea trial, when we do marine stuff, it's always good to, check it at sea if possible.
Yeah, of course.
Sometimes that's not possible and we can, run the machines at the dock.
Yeah.
Especially the cargo equipment, because that's not running at sea.
Yeah.
But, you always want to try to get, like, for main propulsion, it's good to get that under load at sea under normal operating conditions.
Well, you've also got scenarios where it's actually something in the engine or some kind of
load related,
an unbalanced flywheel or something.
Sure.
It doesn't have to be under load. If you're running your engine at idle and you're feeling a vibration, we can go and diagnose it in that condition.
Sure.
So that's the most important thing, is to try and replicate the problem.
Right. And again, going through all the speed ranges. And then you've got things like propeller vibration, cavitation, flow-induced problems, things like that, right? But you get some crazy stuff going on sometimes.
Yeah, I mean, there's a lot of hydrodynamics that go into directing the exhaust gas away from the propeller.
Sure. Yeah. Well, that's why we always want to do a sea trial underway. And, it's good practice to do it in sea conditions less than 1 meter or 3 feet.
Yeah.
So you don't, so we're not getting distracted by wave slap and all those other.
Gotta be in deep water too.
Right.
Have bottom effects.
5 times the draft, right?
Yeah.
Good point. Yeah, there's a lot of things to consider. Marine environments are particularly challenging.
Yeah.
Yeah. So on land, more stable, right?
Much more so.
More predictable loading, right? You want to make sure you get that load on there. The access is usually easier.
Yeah.
In general, right? The environments, and the environment's often more controlled, right?
Yeah.
But where we run into, we were talking about this earlier, where we run into problems on land-based stuff is generally when, for example, like if the machines are elastically matted because they're worried about transmitting vibration into the surrounding environment, or they're concerned about shock loads. Sometimes, they forget that there is creep in mounts and that has to be addressed. Yeah. Or the torsional couplings, they also have those issues, right?
Yes.
The other thing I've seen a lot with land-based applications is things like piping systems. And where you don't have good support on piping, or you don't have proper grouting right in pumps.
Yeah.
And you had a good example with a fuel terminal distribution transfer pump.
Oh,
that was a vertical pump, right?
Yeah, it was what was it, like a 20-stage turbine pump?
Yeah,
something like that.
Right.
Yeah, it's deep underground, and where it came up, it had these like special washers to isolate the metal bolts from the metal flanges to try and eliminate any type of potential spark.
Okay.
So what happened over time is similar to the mouth creep, those compressed.
I see.
And they came loose.
Yeah.
So the bolts weren't providing the dampening required. And this was on a variable frequency drive. So
so you're going through all the frequencies.
We talked about the resonance.
Yeah.
It went through its natural frequency.
Oh boy.
Excited the resonance.
Yeah.
Normally, when it went up to its operating speed, it would stop. This one went up to its operating speed and it kept going.
Right.
And I noticed that if I'd put my hand on it to stop it, it would then stop until the next cycle.
You added mass.
Yeah. Well, no, it was
you added stiffness.
No, it was the dampening.
I don't know.
I wasn't changing.
I don't know if you're that strong, Tony.
No, I wasn't changing.
Well, it's mass damping, right?
Yeah.
Yeah.
Yeah. So what happened was the loose bolts were not providing enough dampening for the resonance to bring down.
Not rigidity.
Yeah.
Yeah.
So it just kept going.
You increase the stiffness by raising the natural frequency by tightening the bolts. Yeah. 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 Stiffness is
now it took
stiffness over mass, right? That's the magic number for natural frequency.
Yeah. Absolutely.
Right? Stiffness over mass.
That was an interesting one.
Yeah. Yeah. We've done some very interesting jobs over the years, right? My very first paying job was on a passenger vessel 33 years ago. And they had they just came out of dry dock and they had this horrible noise, and it turned out to be a singing propeller. The chief engineer was worried that he was wiping his bearings in the line shaft, but I told him he's okay, nothing wrong with the bearings. Your propeller just needs to have a better knife edge on it.
Yeah.
Sure enough, all that went away.
Oh wow.
But you got a propeller that's 22 feet in diameter, and that thing's singing. It's pretty loud. Yeah, it's pretty loud. There's so many issues with pumps and foundations and grouting. I remember when I was doing all the fuel distribution pumps in Port Everglades, they weren't grouted in. So, the piping was pushing the pump all over the place. And when the sun came out, right, here in South Florida, the piping would expand. It would throw the pumps out of alignment, and then they destroy the couplings, and they were constantly changing out couplings, and they'd align it and they would throw it out of alignment. I'm like, yeah, hold on a second, guys.
I don't know if you remember that tugboat with the 2 cardan shafts with the Z drive.
Oh yeah.
And it was like 6 bearings down shaft alley, and
sure,
the pedestals were moving.
Oh yeah,
they're flexing.
Right. Oh, that's scary. Yeah.
So it's causing that dynamic misalignment situation.
Sure. Yeah, got it. It was basically not stiff enough in the transverse direction.
Yeah.
Yeah. So the bearings were moving side to side and throwing the alignment out.
Yeah.
And amplifying the problem. Yeah.
That one would have taken a very long time to find if we didn't have that RDI camera,
which is an amazing tool, which, so we're able to pick up a lot of stuff because we've got some pretty powerful tools in our toolbox.
Yeah, absolutely.
Right? But bearings, some of the things that we've been able to pick up over the years, bearings, shaft bend shafts, right?
Oh yeah.
Gearbox issues, worn out gearboxes, couplings, worn out couplings that aren't mounted on properly, like properly fitted on the shaft, the blue fit.
Yeah.
Propeller, all kinds of propeller issues, right?
Yeah. Yeah. Those, I mean, even with that sinker lift, the gears in that sinker lift.
Oh yeah.
That was crazy.
Yeah, they wore right out.
Yeah, it was like a knife edge.
Yeah, it's crazy how machinery, everything rotates, keeps the world going, right?
Yeah.
So, the whole thing is by a lot of these issues, we come in, we're here we are, guys, we got a vibration problem. We need your help, right?
Exactly.
Man, it sure would be nice if they had a condition monitoring program and they were checking these things like quarterly or monthly. And, we weren't walking into a, walking into the, like a forest fire, jump on fire. Sure be nice if they, we had some history trying to, condition monitoring is not expensive, and the payback and downtime to downtime avoidance.
Yeah.
I think that's by far the biggest cost, right?
Well, think about, remember that we identified a bearing fault in a shaft generator.
Yeah.
And we tracked that thing for like 2 years.
Yeah.
And finally we were like, okay, like it's starting to get a little bad. Let's go ahead and make that, buy that backup shaft generator. And then, okay, it's starting to get a little worse,
Yeah.
Hey, now you've got your shaft generator in storage.
Yeah.
Well, now you're at the point where, hey, now we've got a little bit of downtime. We can shut down, swap it out.
Sure. And it worked.
Yeah.
Saved them a lot of money. And I mean, when you take any piece of equipment in an industrial plant or a ship out of service, it's massive.
Oh yeah.
Marine people think, they tend to, there's a lot of redundancy on ships.
Yeah.
Right.
Yeah.
And vessels. But, if you lose that redundancy, it's kind of scary. You're out in the middle of the ocean somewhere and you're down to one seawater pump or one main lube oil pump.
Yeah.
And the other one's not working.
Oh, absolutely.
Or steering gear.
Yeah.
Oh,
I mean, that's obviously the biggest concern is always safety, right?
Yeah.
But you've also got what a lot of people don't realize or don't think about is you don't only have the cost of the repair, the cost of the replacement machinery. You also have the lost revenue.
Yeah. And downtime is huge.
Yeah.
That's the biggest, by far the biggest cost.
Absolutely.
Losing productivity is, no matter how you measure it, it's crazy.
Yeah.
It gets expensive. And of course there's other benefits like, performance, fuel performance. When a machine's running at its peak, it's not absorbing as much energy. You're not wasting the energy, and you're not, it's good for the environment, right?
Oh, absolutely.
When you're more productive and more efficient with your machinery, it's also better for the environment. You're not wasting resources.
Absolutely. Well, it's like they say, a 1 millimeter offset misalignment can cause up to a 15% lack of mechanical efficiency.
Yeah, which is crazy.
So if you think about that, not only on electric motors, I mean, if you talk about the industrial land-based side, you extrapolate that to 200 motors. I mean,
right.
You're consuming a lot of energy.
And alignment's one of your biggest factors. It's not uncommon for us to find misalignment is one of the bigger factors.
Yeah.
And, people, I can never understand when people don't want to invest in properly aligning, a machine up front. I've always been a strong advocate for precision alignment, and it's a great way to, improve, the paybacks are enormous.
Yeah. I mean, it's like you said, you're going to save on electricity. You're going to save on fuel,
equipment failure.
You're going to save on repairs. You're going to save on components, seals, bearings.
Just get it aligned right from the beginning. I could never understand that why, people wouldn't invest in, buy a laser and do it yourself or hire a company like ours and we can help you. But
we can help them either way.
Yeah. Get it aligned, man. Right.
Yeah.
Right. We can help them either way. You're right. So, proper alignment, less drag, less loss, lower fuel burn, less load, more efficiency, win-win, right? Win-win.
All around.
You don't wear out your shaft seals,
Yeah.
And it's good to make sure you get a company that, knows what they're doing. Yeah, and considers all these factors. One of the benefits we have of being in business so long is, we've seen a lot and we have a lot of experience, and we teach and we share that knowledge, right? We do that every week. You do a tech talk with the guys.
Yep.
We're always training, we're always expanding, we're always buying the best equipment, always trying to do the right thing. Machinery doesn't fail overnight. We're there for you to catch it and make sure it runs right to fulfill its full life.
Right. Exactly. Maximize potential.
Yes, exactly. Thank you very much. Appreciate your time.
Thanks for listening in. We hope you enjoyed our deep dive into this episode's tips and tricks for equipment optimization. Want to learn more? Head over to our website at amesolutions.com or visit our social media channels included in the show notes, along with details from this episode. That's all for now, folks. See you next time.